All right, I'll go ahead and get started here. Good morning, this is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about Industry 4.0 and its impacts in the food and beverage industry. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as a 30% increase in OEE, 50% scrap reduction, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes have to be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. So, as I mentioned, we're here today to talk about food and beverage, and I'll start off by talking about some key challenges, but just kind of a point of reference here. If you have questions, please enter them into the Q&A, and I'll either address them as we go along or at the end of the session. All right, so some key challenges in the food and beverage industry. This is not meant to be a comprehensive list, but it's going to be the key focus for today. I'm going to talk about food safety, quality assurance, recall and traceability, complex supply chains, productivity and changing customer needs, and how Industry 4.0 can help with each one of these different topics. In terms of Industry 4.0 itself, there are a lot of different capabilities underneath that umbrella, but I'll talk about a few particular ones for today. And I'll start off with the Industrial Internet of Things. If you're not familiar with it, it's very much what it sounds like. The I-IoT describes a network of physical objects, sensors, controllers, etc., that feed information into a platform, and that platform can then take different actions. So it can do data collection, data routing, and persist that information. It can do event processing, communication with alerts, and visual controls for the factory floor and so forth. Usually has a development environment where you can put together mashups and user experience, user interfaces. Often has machine learning and AI systems built into it, which I'll talk about next, and usually has a very highly extensible API so that it can act as a hub for information on the shop floor and kind of orchestrate the information flow there. And so, as I mentioned, those systems very often contain artificial intelligence or machine learning applications. And if you are not familiar with these, then generally, if you think about pattern recognition and being able to recognize different patterns in data and be able to either make predictions with that or classify that information into different buckets, that's the most common use of this type of capability. And then augmented reality is another thing that we'll be talking about today. And it's very interesting because where I-IoT, I've been using systems on the shop floor since, like I said, about 2002 to gather information and then utilize that to improve the process. And I-IoT is really just kind of a natural growth of improving those different systems. And machine learning is, artificial intelligence has been around since the 1950s, and it's really come a long way in terms of its capabilities and so forth, but fundamentally it has continued to just evolve over time. Augmented reality represents a truly new capability for the shop floor, where this is something that you just didn't have in place before, and now you can put things out on the shop floor with work instructions that you can actually be looking at the process and have the work instructions overlaid on that so that you can do it without looking away from the process. In a distribution environment, you can do things like visual picking and many different applications that just simply weren't possible in the past. So now, how do I apply these within food and beverage to make a difference? So if I look at food safety, recall, traceability, all of these things linked together. And one area where the technology can make a huge difference is really in enhancing the product safety overall. Product shelf life is a real issue for many food manufacturers who must be careful to control the flow of products and not overproduce. Electronic traceability can play a significant role in solving the issue, allowing producers to track items from delivery to the supermarket shelf. And smart sensors are being included in food packaging to measure changes in microbial activity, temperature, pH, oxygen, CO2 levels, which can provide a more accurate method of detecting food spoilage compared to less accurate, best before dates. And from a product recall perspective and traceability, recalls may become necessary due to customer complaints or food inspections. Pressures growing on manufacturers to institute product recalls as quickly as possible. The traceability of contamination is complicated matter. Several factors such as those microbial impurities, labeling and packaging errors, contamination by metals, plastic, or glass, they have to be taken into consideration. And therefore, processes have to be put in place to identify and eliminate these different sources of error. So this really starts with advanced sensors and I-IoT on the shop floor. And there are many different varieties of intelligent identification systems, which enable much better traceability. For instance, RFID labeling tracks crops from harvesting in order to be able to trace the origins of the cargo. And there are also other systems that allow the systematic and efficient data tracking from raw material to end product. And as you take this information, you'll feed it into basically an integrated work cell. And the sensors feed that information into that IoT platform, which then combines with information coming from the machine itself and metal detectors and everything else to be able to put together that complete context of what's happening on the shop floor. Because the information doesn't just reside at that one station, unlike some OEE systems and things like that. This gives you the ability to create the complete context of what's happening on the shop floor, looking at all of your different test equipment, all the different sensors, all the different controllers for the different machines and so forth, and pull all of that together, as well as giving information back to the operators on the shop floor with work instructions, visual controls, and so forth. And so this can then also integrate into test systems, quality systems, ERP systems, maintenance management systems, and so forth, to make sure that all the information is flowing and visibility is there for all the different systems, all the different people. From an environmental monitoring perspective, even when you're not on the shop floor, you have the ability to track with environmental sensors, making sure that the environment is cold. You can look for cold or warm spots, fine tune the ventilation. You can maintain your documentation and certification within your facilities and so forth, that food has been stored properly the entire time. And you can provide any alerting if things are starting to get out of tolerances and so forth. And then you can also provide cold chain certification across the entire supply chain, where, as I said earlier, you can integrate the sensors coming from different places, whether it's from your upstream suppliers within the factory, within shipping, at the distribution centers, all the way through the retailers, grocery stores, et cetera, to be able to maintain that certification that food was stored properly throughout that entire time. And um, that if you do have a recall, if you do have certification requirements, now you have the information in one place where you can go get that certification for those items. If you do have a problem, you can work backwards through the chain, find out exactly where, what lots and what suppliers everything came from, in order to facilitate that investigation. From just a quality perspective, there are, if you think about typical, fishbone diagram, you have machine, you have man, you have method, you have materials, et cetera, as different sources of variation. And if we look at the machine and how we get variation in the process, you have a lot of different improvements possible from the IoT and machine learning platforms. If you look at the analysis across different processes and see how information is flowing, you have that detailed information there in order to be able to do the predictive analysis, as well as just looking for the details that will lead you to see where you're approaching tolerances, being able to do SPC, not only on the output variables, but looking at statistical process control on the actual process variables themselves, so that you can see where things are trending in dangerous ways and where you might not have control of the process. And this comes from, again, those sensors, the connection to the PLCs and so forth. And so being able to do that real-time production performance monitoring is critical. Being able to monitor not only the high-level output variables and so forth, but really looking at those detailed process variables, looking at temperatures and pressures, and all the different tags that come from the PLC, in order to be able to maintain that quality and maintain really understanding of what are the different sources of variation in the process, and then being able to do Kaizens and so forth in order to reduce those different sources of variation. Another major source of variation in the process is going to be manpower. And it could be new operators. How do you get new operators up to speed more quickly? How do you do error proofing? How do you make sure that you can compare one operator to another, or one shift to another shift, and look for differences in performance? Be able to identify what are those best practices that your best operators have, and be able to then train the rest of the work staff to utilize those same best practices, and utilize standard work as well. How do you kind of identify variations from standard work and then enforce that in the future? And then if you look at methods as another primary source of variation, speaking of standard work, how do you detect deviations from standard work? How do you share the standard operating procedures with your workers? How do you know when they're not adhering to those? How much of a burden is it to update work instructions when you have new products or engineering changes, or et cetera? And how do you do that training for your work staff? And so for both the man and the methods, augmented reality really provides a great deal of assistance to those challenges. It's very easy to do knowledge capture and look at how the experts run the process, whether that's just doing the operator's work, or whether that's maintenance, and being able to share what the maintenance crew does as a best practice to maintain that machine. And then as you're trying to drive towards autonomous maintenance as part of your TPM initiative, being able to train those operators and have that information available to them, whether it's with the augmented reality glasses or whether it's just with a smartphone or a tablet, being able to capture those expert procedures and then share those with the users can provide a tremendous boost to following those standard practices and best practices. In addition, being able to get augmented remote assistance when there are questions and so forth, to provide that live kind of over the shoulder support. So, perhaps you have a new person setting up a machine. Maybe it's not their first time, but maybe they're still not entirely comfortable with what the setup is supposed to look like. Being able to have somebody help them remotely and pretty much immediately, rather than having to wait for somebody to become available to go out to the machine, can significantly reduce the delays. And it also reduces the friction of people asking for help in the first place. If somebody knows that when they ask for help, someone is going to have to come out to the machine, they're going to have to wait, they're going to have to see extra downtime. They may be more reluctant to ask for help. But if they can just basically press a button and get somebody online to answer some quick questions for them, where they can actually show the device and get interactive help right on the screen, maybe they're a lot more amenable to doing that and not having that hit to their productivity and so forth. I mentioned the digital and augmented work instructions, and being able to capture and transfer the expert knowledge is tremendous. The other thing with the 3D glasses or the augmented reality glasses and so forth is that if you think about working a process and you've got whether it's printed instructions or a separate computer screen that has instructions on it, if you have to look away from the process and look over towards the instructions, read the instructions, look back at the process, and then try to get your place back and so forth, it can be very distracting and not an easy flow for a lot of people. But if you have the instructions overlaid right on the process itself, so that as you are doing the work, you see the instructions right there, that becomes a much simpler workflow and much easier for people to get things right the first time. From a productivity standpoint, there are a number of different impacts that Industry 4.0 can have. Basic asset monitoring, utilization. So, how are my resources performing? How do I get that collected and analyzed over time? How do I set up my Kaizen events to utilize that information? How do I pass that information along to the overall improvement process? How do I identify things so that when I have to react to issues, I have that real-time visibility into what's happening on my shop floor and can take actions upon that. So having that asset monitoring in place is just fundamental to being able to improve the process. The predictive maintenance to keep the machines running more effectively can make a huge difference on the shop floor, as many different people have seen. I've been in a lot of food and beverage companies, and a 60% OEE in many environments, especially within packaging environments, is good. It may not be great, but at least it's good. There are a lot of processes that don't even get up to that level. And so by being able to identify what are those primary failure modes and eliminate them through either predictive, where I can say with good confidence that this failure mode is about to occur, so we need to proactively take action to prevent that from happening, or whether it's just having that information, being able to look at what are the biggest problems over time and then address those, can make a significant difference to the performance of the process. One example here is just optimizing part replacements. And as we collect that information from the shop floor itself, it might be vibration, it might be noise, it might be power consumption, it might be different time series data and so forth. And in this example with this customer, we were utilizing ThingWorx as the solution. And so it was connected to those shop floor devices and taking that information in and analyzing that information. We had For instance, being able to predict when a wheel would fail within a machine. We could look at various information coming from the machine itself, looking at where you had a worn wheel and the amount of variation and what the amplitude was on the power draw. And then, if you had a failure, you would see, you know, even greater variation. But then if you have a wheel that hasn't worn yet, you had much lower variation on that process. And so what this allowed us to do was to identify, where that variation had to grow to in order for us to say we need to replace the wheel before we reach that failure point. And we were able to do that using the analytics package and put a good model in place to get that done. And that tied in with that downtime tracking and everything else. And then we were able to present that information on a computer or a tablet with mobile alerts, and then optionally using some of that AR capability as well. I mentioned tying this into a Kaizen process. And for those of you that are doing TPM or lean, you're probably familiar with the Kaizen cycle, and takes a lot of different shapes, but one is fairly typical, where you identify problems, you analyze current processes, you create solutions, you test those solutions, you measure and analyze the results, and then you standardize. Well, every single one of those steps is dependent upon data to some extent. And you can utilize this data collection through IoT to really transform how you do Kaizens, whether it's from how you target those, or how you analyze the process, or go through this entire cycle. Having that data, having that analysis capability makes just such a huge difference in terms of the effectiveness of the Kaizens that you run. So one example with this, in terms of analyzing the current process, is I was working with a bread manufacturer, and so we looked at the information coming from the shop floor, pulled that into a system to analyze that, and with that information, we categorized each stoppage of the equipment, whether it was an equipment loss or a quality loss, run speed, changeover, etc. A categorization, so what was it within the process that had an issue, and then what was the particular cause for that stoppage. And as we would go through, you can click on equipment loss and drill into it, and then you could drill into the top category, which was oven within equipment loss. And what we saw was that the shape of this time series information changed dramatically once we did that. Instead of having the significant amount of loss every single day, we really just had these spikes of downtime. And what was happening is that the oven shelf was flipping due to broken pins. So the pins on the conveyor were fatiguing over time in the oven after a certain amount of time spent heating up and then cooling down. And once we realized this was happening, we were able to put a preventive maintenance plan in place that changed out the pins every once in a while, checked them for fatigue and so forth. And by doing that, we were able to eliminate the single biggest source of downtime in the plant. Now, if you would talk to the people in the plant, they could have told you that, hey, every once in a while that stuff happens. But without realizing how much it was happening and how big of an impact it had, management had never prioritized that for an improvement event in the past. And so by being able to see that information, we were very clear on what needed to be done to eliminate that big source of downtime. Managing complex supply chains is also a very big deal in food and beverage. Not only do you have the typical distribution needs and so forth, but we talked earlier about being able to do tracking and tracing across the entire supply chain, and being able to have that cold chain certification and so forth. And so you have more needs for data collection throughout your supply chain than is typical in, say, a durable goods environment and so forth. And so some of the key trends that we see in warehousing and distribution are the end-to-end inventory tracking, vision picking, data analytics, guided vehicles and robots, drone picking and drone utilization of drones for just doing inventory counts and things like that. Blockchain item tracking across different elements of the supply chain, and automated tasking and so forth. And so each one of these, again, is very much related to IoT, Industry 4.0, and the utilization of data. When you look at visual picking, whether it's done as shown here with a tablet or whether it's with the glasses and so forth, it really helps employees effortlessly pick items and transport them to a different zone in the warehouse. Since connected wearables have very intuitive interfaces, learning to use them takes less time than memorizing the location of each type of goods and having to reach it manually. These vision systems help reduce the number of paper documents and track product lots automatically, thus, increasing the productivity of the warehouse. So, being able to have these increases your picking accuracy, helps your picking performance, and also provides better ergonomics for your people. Automated material handling systems, and again, this is more of an evolution than revolution, but the material handling systems and the integration of the Industry 4.0 capabilities can automate these to a much greater extent than has been possible in the past. Basically being able to incorporate those barcode readers, the vision systems, RFID, et cetera, and having all of that information feed through that IoT system for the control of the process as well as the data collection. And speaking of the vision systems, being able to utilize those to be able to spot where you have damaged goods and other issues can be of a great benefit as well. Changing customer needs is another thing that food and beverage has to deal with. So the food and beverage industry is probably the manufacturing sector most directly exposed to changes in patterns of household consumption. Although the number of people in the country and how much we eat fluctuates very little, the consumer preferences alter considerably over time, requiring manufacturers to respond and adapt to those changing needs. One thing that's been something of a holy grail for every industry, but has been particularly difficult in food and beverage is single unit production. And while that's been extremely difficult to implement, some enterprises are moving in that direction. The possibility of automation and previously mentioned sensor technologies enable customization according to client requests. A well-known example are granola packages that are custom mixed and shipped to customers with their own labels. But whether it's getting down to single unit production or whether it's just being able to run smaller and smaller lots in an economic fashion because you have faster changeovers and everything else, are improvements that you can make in order to get your production closer to customer demand, be able to reduce your finished goods inventory, be able to reduce the amount of time that food has to spend in the supply chain as opposed to going directly from the plant to the table. Intelligent labeling is another emerging technology, and the combination of the wireless labeling software applications and cloud platforms lets consumers scan product labels with their smartphones to ensure the product's authenticity or to obtain information regarding ratings, customer loyalty programs, or product videos. Just requires a near field communication device, or again, the QR codes and things like that. The data that these intelligent labels provide can contain demographic information, location, likes, social shares, and the exact amount of data retrievals. And enterprises are even testing strategies such as extending the shelf life of fresh products or minimizing food and packaging waste with this process. Um, Another subject that comes up a lot when I talk to food and beverage companies about Industry 4.0 is MES versus IoT. And there are strengths to each system. MES has been around for decades, and it's had that decades of development and refinement to it. So it's very well established functionality, data models, integrations. It has a very broad suite of solutions. It's built to act as a system of record, and especially in validated environments and so forth. And it can be a common system across different sites. IoT generally has more modern architectures. It's nearly infinitely flexible for these platforms. It's built for connectivity. It's built as a hub for shop floor data as opposed to owning the shop floor data. And it can be the center of different best in class solutions, and it very easily coexists with other systems because it doesn't need to own the data. Some specific use cases where IoT functionality may be desirable, and these are just kind of random examples as opposed to being a comprehensive list. This is just a tiny fraction of the different use cases that it supports. But being able to create a UI to display if a unit has passed all tests and should be sent along to packaging. And being able to integrate to all the different pieces of that and gather that information, put custom logic in place to be able to say yes or no, basically. Being able to analyze external information such as temperature, humidity, impact on the process. Developing a correlation between product and process, CPK. Combining machine data with PLC or SPC data to do predictive analysis. Using RFID data, on someone's badge to do spaghetti charting, or tracking fork truck or lift cart usage within the plant, and being able to track and optimize the routes and so forth, where to leave them when they're not in use, and so on. Some custom applications that I've worked on with customers utilizing IoT systems outside of MES are being able to basically build a custom FMEA application that combines your process and product FMEA information with the information that's coming from the shop floor, so that you can continually update what is your probability of failure, what is your probability, what is your severity, and then what's your probability of detection. And utilizing IoT and different sensors to increase that probability of detection for the different failure modes. Automatic value stream mapping is something that I've seen done within industry, where you can take this information and automatically create your value stream maps and keep them up to date, and not only look at what is the mean time for value add and non-value add activities, but what is the entire distribution for those different activities. Creating a digital management operating system utilizing this information from the shop floor, and how does that all aggregate up, and how do I tie that into my different KPIs across safety, quality, delivery, cost, inventory, manpower, environmental, and be able to track all of those in real time from all of the different sources that information can come from. Creating custom visual controls for the shop floor and so forth. And so again, just endless possibilities with these systems and what can be done with them. So some closing thoughts here on some additional challenges within food and beverage. Retaining clean labels without compromising taste. So the obesity rate has doubled worldwide from 1980 to 2014. The correlation between sweetened grocery items and obesity is pretty well documented. For companies that produce soft drinks or kids drinks or protein-based beverages, or a variety of different foodstuffs, reducing sugar content will be greater priority in the near future. Presents a huge challenge, though, in terms of reducing the amount of sugar while maintaining that taste of the different products. And research and development is currently underway and full speed ahead to find natural ingredients that provide the same familiar taste, but can be marketed in the form of clean labels to address the needs of health conscious consumers. And there are different technologies that can be put in place in terms of some of the sensors that can basically smell and so forth, that can look at the ingredients based on fresh ingredients and being able to maintain a consistent flavor with the more natural ingredients as opposed to the manufactured ingredients. And how do you maintain that same flavor profile for your products while also being more natural and so forth? Harmonization of legal standards. The legal standards that the food and beverage industry faces are continuously evolving, not just here in the States, but across different countries. And being able to face all of those traceability and other regulations that you have to maintain, and being able to have that all tied in and contextualized for those different regulations is a challenge within the industry, and being able to have that raw data that you can process in different ways and apply these different standards to is very important. And then just the increasing specialization. I've talked some about changing customer needs and requirements and so forth, but the array of choice for consumers is overwhelming these days. And the rapidity with which people are evolving their tastes is continually increasing. And just the constant shifts from one level of health to another is very rapid, and being able to keep up with those changes is something that Industry 4.0 can assist with over time. With that, I want to thank you for your time today. If you have questions, please reach out to me at tim@visualdecisions.com. My phone number is right there as well. I don't see any questions in the Q&A, and so with that, we'll call it a day. Thank you very much again for your time, and I look forward to following up with you all. Thank you.